Today's lesson is about comparing and ordering scientific notation. The lesson objective for this lesson is that by the end of the lesson, I can compare numbers in scientific notation to determine which one's larger, which one's smaller, or to put them in order and make sense of them. There's no new vocabulary for this lesson, so we're going to go ahead and jump right into it. We're going to look at numbers in scientific notation, and we're going to figure out how to tell which one is the smallest and which one is the largest. For this particular example, I'm going to go ahead and write the numbers in from scientific notation into standard form so that you can see why some of the rules work with the exponents. So let's look at this. 3.156 times 10 to the negative fifth. The negative tells me that I am going to actually make this coefficient, remember this is called a coefficient, I'm going to make it smaller. And so I'm going to move my decimal place 5 places to the left. Okay? So let's try that. I have 3, 1, 5, 6. My decimal place was here. I'm going to move it 5 to the left. 1, 2, 3, 4, 5. My decimal place will go here, and I have to add zeros in front. See how little this number is? It's way out there in place value. So let's change this one into standard form. Okay? So it's 1.25. I'm going to erase that real quick, that point. Okay, and I'm going to move it 4 to the positive, which means I'm going to make this number larger. So I'm going to move it over 4. 1, 2, 3, 4. My decimal place would go here, and I have to add zeros to it. And when I do that, I get 12,500. Well, once I write them in standard notation, it's very easy to tell which number is bigger. Obviously, this number is larger. It's okay for you to change everything from scientific to standard if you need to, but there's some other things you can look for. For instance, if you notice this is a negative 5 and this is a positive 4. Negative 5 is less than positive 4, and I can tell you that every time that happens, that specific number is going to be smaller than the number with a larger exponent. Okay, so let's look at these two examples and see if that is really the case, okay? When I look at my exponents, I know that positive 4 is larger than positive 3. So I'm going to assume that 5.406 times 10 to the fourth power is actually larger than 5.504 times 10 to the third power. I want to write that in standard notation so that I can prove to you that it actually works. So 5406, I have a positive 4, so that means I'm going to make my number larger, and I'm going to move my decimal place 4 times. 1, 2, 3, 4. So this number in standard notation is 54,060. So let's change this one into standard notation. I have a positive 3, so I move 3 times to the right. 1, 2, 3. And that makes this number 5,504. So was my statement true? Yes, it was. That happens every single time. Okay? The larger the exponent, the larger the number. So if I'm comparing these numbers in scientific notation, I want to find out which number is the least, okay? Use the rule I just told you and determine which one you think is the smallest, and we'll see if you're right. So pause the video, choose which one you think is the smallest, and then you're going to have to tell me why. Okay, so let's use the rule we talked about. This exponent is a 4, this exponent is a 5, this is a 4, and this is a 9. So what I know is that the 4s are the smallest, right? So these are not the least because 5 and 9 are bigger than the 4 in the exponent's place. But now what do? I have 9 times 10 to the fourth power and 1.901 times 10 to the fourth power. Well, if you have two numbers that have the same exponents, that means that you're going to add the same number of places to it, okay? When you do that, you can actually look at your coefficients to determine which one is the smallest. When I look at this, I have 1.901 and I have 9, okay? 1.901 is actually smaller, so that makes it smaller. Let me show you standard form so you can see that that actually works. So 9, and then I add 4 places. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that gives me 90,000. This is 1 and 0.901, and I'm going to move it 4 times. 1, 2, 3, 4. I add a 0. This one is 19,010. So we were right. 1.901 times 10 to the 4th is the smallest number, the least. So what you're first going to look at is, number 1, you look at exponents. And if those are the same, then you look at their coefficients. All right, so using what we just talked about, put these numbers in order from least to greatest. Arrange these in least to greatest. So the first you're going to do is look at the exponents and put them in order from least to greatest. Then if you have exponents that are the same, you're going to look at their coefficients. Try this one by yourself and we'll see if you can do it. All right, let's see how you did. So here's what I see. I have a 6, a 4, a 5, and a 4. So I know my 4s are the least, right? And now I have to look at their coefficients. 5.1 is greater than 4.09, so I know that this is the smallest. This is the next smallest. Then I look at my exponents again. There's a 5 here, so this is next, and this is last. How'd you do? Okay, so try this one by yourself and see how you do. Oops, I apologize. This is the wrong slide. Go ahead and skip this slide and move on to the next. Okay, so here's the next thing that you might have happen when you are ordering or comparing. Let me read the story problem to you. During 1 year, 2 times 10 to the 7th U.S. students were enrolled in college. That same year, 4 times 10 to the 6th U.S. students were enrolled in private schools in grades 1 through 12. For that year, about how many times more U.S. students were enrolled in college than in private schools? Holy cow. When I look at that, I think to myself, I don't even know where to start. So here's how you start, okay? There's a process that you go through to see which one of those is larger and how much larger it is, how many times larger it is. So let's follow the process. A tells us to circle the greater number. Well, I know that since both of these have exponents and the 7 is larger, that this is my greater number. Okay? So I'm going to rewrite 2 times 10 to the 7th so that it has the same power of 10 as 4 times 6 to the, 4, Mrs. Hall, you're losing it. This is 2 times 10 to the 7th, and this is 4 times 10 to the 6th. I want them to have the same power in order for me to find out how many more times one is than the other. Okay, so I'm going to rewrite 2 times 10 to the 7th power, okay, so that it has the same power of 10 as 4 times 10 to the 6th power. Here's how that's going to work. You ready? I take the 2 exponents and I subtract them. 7 minus 6 equals 1. Now I'm going to move the decimal place 1 place to the right because the number is bigger. Okay? Now I'm going to compare the coefficients. All right? So it was 2, and I'm going to move it 1 place to the right. That gives me 20. Now they have the same power of 10. All right? So the coefficients are this. Now my new coefficient is 20 for my 2 times 10 to the 7th power because now it's times 10 to the 6th power. My original coefficient for the other number is 4. I'm going to divide these. 20 divided by 4 is 5. Okay? So when I look at the question for that year about how many times more U.S. students were enrolled in college than in private schools, 5 times more. So the process is this. Change them to the same power of 10. Compare their coefficients, and that tells you how many more times something is than the other. So here's another one like that. The average distance from Pluto to the Sun is about 6 times 10 to the 9th kilometers. The average distance from Mars to the Sun is about 2 times 10 to the 8th kilometers. The average distance from Pluto to the Sun is about how many times as great as the average distance from Mars to the Sun? Try this one by yourself. Remember, you're going to take the greater number and make it the same power of 10 as the smaller number. Try it and see how you do. All right, let's see how you did. 6 times 10 to the 9th is the greater number. So we're going to write that in. We're going to rewrite 6 times 10 to the 9th so that it has the same power of 10 as 2 times 10 to the 8th. I look at my powers and I say 9 take away 8 is 1. So I'm going to move my decimal point one place to the right. When I do that, that gives me 60. So now I have 60 divided by 2 equals 30. Okay? Those are my coefficients. The average distance from Pluto to the Sun is about 30 times as far as the average distance from Mars to the Sun. This is a process, and as you do it, you'll be really good at it very quick. You just have to take your time, okay, and try it. Write all this down. We'll talk about it tomorrow, and we'll do some work with it.